Okay, all right. Let's talk about a few things here. First of all, let's review one little thing, a little bit that we talked about that we'll need throughout our time together here today. Let me draw a Venn diagram and set A and B again, just two set Venn diagram. And let's just put 1 and 2 in here, and then 3 here, 4, 5, and 6 out in there, and then element 7 out there. Just putting some elements, placing elements just randomly kind of through there. What I was going to hit here real quick is, number one, what elements are in A and B? What elements are in A and in B? Well, we talked about this last time, previous lecture, and when we say what elements are in A and in B, remember what that means? Well, for our purposes, in sets and in different places, and means what they have in common. And means the intersection. In other words, when I'm asking what elements are in A and in B, I'm asking what elements happen to be in both A and in B. In other words, what's in the intersection. So if it's what elements are in the intersection, well, there's only one element in the intersection. That would be element 3. On the other hand, what elements are in A or B? Or means what? Well, or means the other. It means the union. Which elements are in A or in B? In other words, which ones are in one or the other? Well, 1 and 2 is in A, and then 3 is in A and B. 4 and 5 and 6, all those elements would be in A or B, in the union of the two sets, in other words. So if we ask a question that has and in it, we're talking intersection. And means the intersection. Or means the union. Because or typically means it's in one of the sets or the other or both of the sets. And on the other hand, it has to be in both sets to be included. Okay? So I wanted to mention that, and we'll deal with that more in a moment. Okay?
So how would you say the or can be in either one?
Yeah. Or, if I ask you, are you in a math class or a science class in the fall semester? Well, you would answer yes if you were in a math class, right? Maybe you weren't in a science class. You could still answer yes there. So it just has to be in one of them, you see, for or. Now, if I ask you, are you in math and science next fall, you have to be in both, right, to answer yes on that. So that's the same thing. And it has to be in both, or it's in one or the other, but it's and is the intersection, or is the union. Okay. All right, let me talk about, there's a formula actually we need to talk about for this section. We'll get to it in just a second, but let me just start with this little example here. Say I know the number in set A is 6, the number in set B is 5, or write that there. That's what does this mean? N of A equals 6. The number of elements of A is 6. The number of elements of B is 5. Could you tell me then this? Which means how many elements are in the union of A and B? Well, I can't really tell you right now. Here's why. Yeah, it's not going to be any more than 11, but why is it maybe not 11? Because there may be what? Maybe some overlap. You know, when I say the number of, that's talking about the number of distinct elements. So if A and B have some common elements, well, let's just take us for example. Let's say A, we want to have 6 elements, so A is going to be A, B, C, D, E, and F. B is A, E, I, O, and U, the vowels. So doesn't that have 6 elements for A? 1, 2, 3, 4, 5, 6. 5 elements for B? A, E, I, O, and U. What's the union? And then we'll see how many is in the union. Well, the union has A through F. Right? But so what are the others? Union just means put them all together, so what else has it got? I, O, and U. So it turns out here the number in the union is 1, 2, 3, 4, 5, 6, 7, 8, 9. Why isn't it 11? Well, because there's some overlap, right? I've got some overlap here, and when you write sets down, you don't include those elements, right? You don't write elements more than twice. We talked about that last time too. Writing an element once is all you need. Writing it twice doesn't add anything to the set. So, yeah, there's some overlap. When I wrote A through F, that was A. Well, when I came to B, then I didn't need to write A and E again, just I, O, and U. So that's why the sort of the number shrunk there. Okay. Well, if you think about it, though, there is a relationship between these and this, and then there one other thing here we'll talk about, and that's what we're going to talk about here, where we're going with this. That is the what the book calls the cardinal, or what's known as the cardinal number formula. You remember, the cardinal number just refers to the number of elements a set has. And what the cardinal number formula does is it relates several different cardinal numbers all together, these that we're talking about. Okay, so what we saw was the number in A union B. Yeah, we do want to add the number in A and the number in B. However, that's not the whole story because of the overlap. What I have to do is actually maybe subtract a little bit, and what I wind up subtracting is the intersection. If you think about it, that would work in this case, because in this case I have 6 in the A, right? In my scenario here, A was 6. What's B, the number in B? 5. And what about this number in A intersection B? How many is in the intersection? I haven't written that out, but what's the intersection of these two sets? Be A and E, wouldn't it? Where they overlap. So A intersection B has how many? 2. And so you see that works out, because 6 plus 5 is 11, then subtract 2, you get 9, which is exactly what we saw it was. Okay? So what this does is that you don't have to necessarily know these elements. It could be any elements. What you need to know to find the union is you need to know the number in A, the number in B, and then the number in the intersection. If you know those three, then you can find the number in the union. For example, for another example, okay, if I had the number in A is 30, the number in B is 45, and the number in the intersection, A intersection B, is 22. How many? Could you tell me how many are in the union there? Sure could, because the number in the union, how would I do it? Well, I'd take the number in A, which is 30, add to it the number in B, and do what? Which is 75, but what else do I need? Then subtract the 22, right? The number in the intersection. So if I add the number in A and B and subtract the 22, that's going to tell me, without even knowing the sets, how many is in the union. 75 minus 22 is 53. Okay? All right. Now, should also point out that you don't necessarily have to have just these three to get this one. Let's think about this. What if I had the number in A is 15. The number in B, or the number in A intersection B, is 5, and the number in A union B, let's make it 18. Well, I already know the union. I know the intersection of A. The question here would be, can I figure out how many's in B? And the answer is, I can do that. I can't figure that out. Yeah, it turns out in that formula, we're still going to use the same formula, which what was it? Number in A union B equals the number in A plus the number in B minus the number in A intersection B. I'm still going to use that formula. I just have different parts here given to me, or I've two parts switched out here, and what I know. What I don't know is the number in B, so I can't fill that in, but I can fill in the others, can't I? I can fill in these other three. I know how many's in the union, so I know that's 18, so 18 here. A is 15, so 15 here. I don't know the number in B, so it's got to stay unknown there. And the number in A intersection B is 5. Yeah, I can figure out the number in B that way, can't I? The relationship still has to be the same as before. Maybe a little different scenario solving-wise, but treat it like an equation. I've got on this side, I can combine the 15 minus 5, can't I? So just combine those. That's 10. So what's the number in B need to be? Well, 18 equals 10 plus what? Subtract the 10 or whatever you want to do, but doesn't the number in B have to be 8? Yeah. The number in B there. Is everybody okay with me on that? Yeah. So as long as you have 3 of the 4 parts in this formula, you can figure out that 4th part. Whether it's this part or that part or that part, you can figure it out. Okay?
So we're not actually add, subtract. We're doing subtract.
Yes. Yeah, we got to subtract, and then we're going to subtract again. Yes. Okay. Just kind of solving the equation there. All right? All right. Okay, let me reboot here.